Konnichiwa, Toyama Kentaro to moshimasu. Hi, my name is Kentaro Toyama, and I am the Assistant Managing Director of Microsoft Research India. I also run a group that's called Technology for Emerging Markets, and what this group does is formal research to find ways to apply computing technology and other kinds of electronic technology to the socio-economic development of very poor communities around the world. We have projects in agriculture, in healthcare, in microfinance, education, and many other domains of development. And in every case, what we try to do is follow three very broad steps to ultimately find a good innovation that works and then to evaluate to make sure that it works. The first step is something I call immersion, where the goal is to use various ethnographic techniques to thoroughly understand the environment in which we are hoping to have an impact. And in this phase, the goal is for us as researchers to get as much intuition as we can about the particular environment that we're working in. So for example, if we're working with rural farmers, then we will actually spend months in the field to understand the way that rural farmers live their daily lives, what kind of interactions they already have with existing technology, what kind of needs they have, what kind of desires they have, what kind of dreams they have for the future, and so forth. And then that immersion phase leads to a certain amount of intuition so that we can actually identify real problems that people face and then get a hint as to what kind of solutions might work for them. And that's when we go into the second phase, which you might consider design. And in this phase, what we try to do is either invent or innovate or adapt new technologies which we think will solve a particular kind of problem. And we also design a kind of overall social framework in which that technology will actually work. So very often it's not enough to just design the technology, you also have to understand how a particular community will use that technology. During the design phase, that's when we bring all of our talents together as technologists, as designers, as social scientists, as hard scientists, and to find ways in which some combination of innovations will solve a particular problem or reach a particular objective. It often takes a lot of iterated prototyping where we prototype a particular idea, test it in the field, and repeat this exercise until we are confident that we have an innovation that really works. Occasionally we find that no innovation works, in which case we assume that this is a very difficult problem to solve and possibly go on to a different challenge. In those cases where we find innovation that we think works well, then we ultimately do a rigorous evaluation, and that's our third phase. During the evaluation period, what we try to do is something like a randomized control trial where we can test what happens when we use our particular innovation and compare it with some baseline case which we consider the control case. And to the extent possible, we try to make sure that these studies are statistically significant and ultimately result in a very clear causal relationship between the particular innovation and the output that we're seeking. And if that evaluation goes well, then effectively what we have is strong, rigorous scientific proof that the innovation that we worked on is having a certain kind of impact. When you put all three of these things together, it creates a very powerful system of innovation that can often find answers to solutions and then furthermore provide the proof that those innovations work. I'll just give you one example of such a project. We were looking at education and rural education in particular, and we found that many of the schools in India that already had PCs were often used in a situation where many children crowded around a single PC. So that was the immersion. And what we wanted to do was to effectively provide every child with some way to interact with the computer, and that led to a very simple technical design where we allow multiple mice to be plugged into a single computer, and for each mouse there's a corresponding cursor on the screen. That turns out to work very well. Kids love it, and so we went on to an evaluation phase where we tested the system with 200 students on a very simple English vocabulary learning exercise. And what we found was that children learned as much with multiple mice, with 5 children to a single PC, as they did if one child had one PC all to themselves. And that resulted in effectively convincing Microsoft that this was an interesting product for them to pursue.